Good morning, Pre-Cal. Today we're going to continue with Trig, and today we're going to talk about how to graph sine, cosine, and tangent. And a couple things you need to remember are the quadrants and their signs, which we have already talked about. Remember, all students take calculus, and that shows you the positive trig functions in each quadrant. All the others would be negative. So keep that in mind as we go through this. Sine, cosine, and tangent functions, the points that you need to graph those are all off the unit circle. So they're only going to be at the major coordinates like for 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sometimes we'll get into breaking that down into smaller increments. But otherwise, very easy to come up with the points to plot sine, cosine, and tangent. And if you go through this, cosine, remember, is the x value. So if you have your unit circle handy, you can fill this in. So cosine of 0, if you think about the point out there at 0, cosine is the x value. That's out here at 1, 0 on the unit circle. So cosine would be 1. You look at cosine of pi over 2, that's up on the y-axis, positive y-axis. Cosine there is 0. Pi, out at pi on the negative x-axis, cosine is negative 1. At cosine of 3 pi over 2, down at the negative y-axis, the x value down there for cosine is 0. Over at 2 pi, we're back around a full circle, so that is 1. Cosine of 5 pi over 2, we're continuing on. That's basically 2.5 pi, so we're back up there at 90 degrees. So that's going to be the same as pi over 2. That's going to be 0. And also, if we go into a negative direction, we look at the unit circle and we go negative pi over 2 or negative 90 degrees. That puts us down here at 3 pi over 2. So that's going to be the same as 3 pi over 2. It's going to be in a negative direction. Cosine of negative pi is in the same position as cosine of pi. And cosine of negative 3 pi over 2 is the same as if we went cosine of pi over 2. So that's going to be back at 0. So all these you can get from the unit circle. So it's best to have your unit circle handy or memorize it. So we're going to graph sine of x. Remember that sine of x always starts at 0, 0. Okay? Sine of pi over 2, it's either going to be negative 1, 0, or 1. And if you look back at the first sheet, it should tell you it's at 1. Sine of pi, we're back at 0. And sine of 3 pi over 2, we're at negative 1. And sine of 2 pi, we're back on the axis at 0. We go in a negative direction. Sine of negative pi over 2 is negative 1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is at 1. And sine of negative 2 pi, we're back at 0. So if we connect the dots, sine looks like this. This is a periodic function. It runs in cycles. So after 2 pi, so if we go from here to here, that's one cycle. After that, sine of x just repeats itself. So the period of the sine function is 2 pi. This is one period. From here all the way to here is one period. Also, we need to discuss the amplitude. Amplitude is a height. Here's the amplitude, and if you divide it by 2, okay, so that distance divided by 2, the amplitude for sine function is 1. It has no sign, it's a measure of a distance. Okay? So those are the two most important numbers we can get out of a sine or cosine or tangent function. Cosine does not go through 0, 0. Sine of 0 is at 1. You can get those off the second page of notes or first page of notes where we filled them in. Sine of pi over 2 is 0. Sine of pi is -1. Sine of 3 pi over 2 is back at 0. And sine of 2 pi is 1. We go in the negative direction. Sine of negative pi over 2 is 0. Sine of negative pi is -1. Sine of negative 3 pi over 2 is at 0. And sine of negative 2 pi, we're back at 1. So this is what the cosine function looks like. Again, its period is going to be from here all the way to here. That's the period. That distance is from 0 to 2 pi. So the period is 2 pi. And the amplitude for the cosine function is 1. Now, changing some numbers, like the number that goes in front of cosine is the amplitude, sometimes that can be higher than 1 or lower than 1. Sometimes there can be a number in front of the x. That changes the way the graph looks. Sometimes there can be a number after the x that makes the graph go up or down. So all the same transformations that you've seen in other algebraic functions are the same. So the amplitude is 1. This is how far up or down the graph goes in either direction. The coefficient of the trig function gives us the amplitude. So that's the number in front of the trig function. A negative coefficient will flip all of the y values. So they'll flip it over the x, just like it would in any other function. So let's see what happens when we put a 2 in front of the sine. I'm going to draw y equals sine of x. And I'm going to draw that as a dashed line so you can see what happens. Whoops, got off line there. So that's y equals sine of x. But we've got 2 sine x. So what that does, it stretches the graph. Okay? It stretches it up to 2. So all these points that are at the hills and the valleys will stretch from -1 down to -2 and from +1 up to +2. And it'll look like this. Let's see if I can get this right. Okay. So the red line is y equals 2 sine of x. It stretches it up and down longer. So that's what amplitude does to a graph. Let's look and see what happens to the sine function when we put a negative in front of it. So again, I'm going to draw y equals sine of x, just so you can see what happens to the parent function. So there's y equals sine of x. If we flip all the y values to where they went the same distance on the other side of the x-axis, in other words, we're flipping it. This is on the x-axis, it's going to stay. This one is going to come down here underneath. This one stays the same. This one is going to go up here. This one stays the same. This one's coming down below. At pi, it stays the same. At 3 pi over 2, it's going to go above. And then at 2 pi, it's going to stay the same. So this is what negative sine x would look like. Okay. In order to graph trig functions on a TI-84 calculator, your mode needs to be set in radian. And I'll show you how to do that in just a moment. We've talked about the period. The period of function is how long it goes before it repeats. So the period of the sine function is 2 pi. The graph looks exactly the same from 0 to 2 pi as it does from 2 pi to 4 pi, 4 pi to 6 pi, and so on. And the same is true for cosine of x. To find the period of a trig function, we want to take 2 pi and divide by the coefficient of the x, the number in front of the x. So that's what we're going to do with these few examples here. We're going to find the amplitude and the period. So the amplitude is just the number that's in front of the trig function. So our amplitude is 3. The period is going to be 2 pi divided by the number in front of the x, which which is 2. And that gives us, in this case, pi. So this graph is going to repeat every pi units. It's going to look the same from 0 to pi as it does from pi to 2 pi. All right, next one. We can rewrite this one if the fraction gets you confused. Negative 2 sine. This is really the same as 1/3 x. So my amplitude is the number in front of sine. Don't worry about the positive or the negative. So my amplitude here is 2. My period is going to be 2 pi divided by 1/3. Remember, to divide by a fraction, the rule we learned in elementary school or middle school was flip it and multiply. So if I flip this fraction and I multiply, I'm going to get 6 pi. And when you're graphing these, the period is going to come in handy to tell you how to make your x-axis scale, and the amplitude is going to give you an idea on what you need to make your y-axis scale. So we're going to graph y equals cosine of x over 2, or 1/2 x. So the period is 4 pi. We get that by taking 2 pi divided by 1/2. We get 4 pi. So if I've got it stretched out to 4 pi, I need to go to 4 pi on the positive x-axis, and I need to go to negative 4 pi on the negative x-axis. So I want to divide those into 4 because there's 4 major points that I need to make in one cycle. So therefore, I'm going to have points at pi, 2 pi, 3 pi, and 4 pi. So here's what it would look like. I've got to make sure I have pi, 2 pi, 3 pi, and 4 pi. If you want to put others in there, that's fine. So remember, if I'm graphing cosine of 1/2 x, cosine starts at 1 on the y-axis. So I'm going to have one at 0. I'm going to have a point at pi. I'm going to come down. I'm going to have the bottom point at 2 pi. I'm going to go back up to the x-axis and put a point at 3 pi. Back up to 1 and put a point at 4 pi. So we'll start here. And that's what it looks like as far as one cycle. I should draw one in the negative direction also. So this graph looks more stretched out. I don't know if any of you have ever played with a slinky, but if you stretch out a slinky, this number's changing. If you compress the slinky, it's going in the other direction. Now we're going to graph y equals cosine of 2x. So if we calculate the period, 2 pi divided by the number in front of the x, we get pi. And if I divide that by 4, I need to make 4 points starting in a scale of pi over 4. That means pi over 4, and I add another pi over 4. And then I add another pi over 4. And then I add another pi over 4. So those are my major scale points. Okay. I got it going in both directions. You can put more numbers in there if you like. Again, this is y equals cosine of 2x. Remember, cosine starts up here at 1. So I'm going to hit at pi over 4. I'm going to be down below 3 pi over 4. And I'm going to hit again at pi. If I keep going and I want another, I blew those points, went right by pi over 2 and pi over 3 pi over 4, and then back up at pi. That's one cycle, one period. Okay. If I want to go another one, I just keep going. I put a point here, go below, come back up, hit the line, finish up here at 2 pi. I want to go in a negative direction. Do the same thing. Keep going. Whoops. Get off track. So the bigger the number is in front of the x, the more compressed the spring looks like. You consider this a spring like a slinky. The closer they come together, the bigger the number is in front of x. Tangent is a little bit different from cosine and sine. Tangent has some points where it's undefined, so you're going to have some asymptotes, vertical asymptotes in the graph of tangent. So here are the points for tangent. Tangent is 0, 0, tangent of pi over 2 is undefined. So at every half pi, it's undefined. Okay? And at the undefined numbers, they're vertical asymptotes. So we're going to draw tangent of x. So we're going to have vertical asymptotes at every half pi. And we can draw them in there, just dashed vertical lines. And then for tangent, you're going to start and go down from the left and up on the right. Remember, tangent of negative pi will be 0. Looks like that. Tangent of 0 was 0. Goes to that point. Tangent of pi was 0. So that's how tangent looks. Very different from sine and cosine. To graph secant, cosecant, and cotangent, we're just going to flip the graph of the function that it goes with. Okay? So here's what that looks like. If I want to graph secant, I'm going to graph y equals cosine as a dashed line. So here's the points for y equals cosine. So I graph that because that's the basis of y equals secant x. If I want to graph y equals secant of x, at the top of the hill and the bottom of the valley, there is a parabola. So the blue lines are y equals secant of x, but we used y equals cosine, the reciprocal function, to find that. All right. So now let's look at cosecant. Cosecant is the reciprocal of sine. So I'm going to graph y equals sine of x first, because that will help me get the graph of y equals cosecant of x. So at the top of the hill and the bottom of the valleys, we put a parabola. If they're at the bottom, they open down. If they're at the top, they open up. So the blue lines are y equals cosecant of x. If you want to come back and erase y equals sine, you can do that. And that's what you would have left. For cotangent, notice that the vertical asymptotes shift to be at every pi value, there is a vertical asymptote. So at 0, at negative pi, positive pi, negative 2 pi, positive 2 pi, there's a vertical asymptote. And the cotangent changes direction. Remember, tangent went this way. Well, cotangent's going to go the other way. It's going to start up top on the left and come down. Okay. So the blue lines are y equals cotangent of x. Okay. So let's look at how to do it on the calculator. So first thing, I go to mode, and I want to make sure my mode is in radian, and we are. So go to y equals. Suppose I wanted to graph y equals 3 sine of 2x. Three sine 2x. My amplitude is 3. That tells me what I need to make my y values. And my value in front of the x is a 2. So if I take the period, 2 pi divided by 2, I'm going to stretch out my period to pi. So I go to window. Period gives me my x min and my x max. I want to go to negative pi to positive pi. Remember how we took pi and divided it by 4? And we got pi over 4 to make 4 points. So I'll make my x scale pi over 4. That's going to give me a point at pi over 4, pi over 2, 3 pi over 4, and pi, going in both positive and negative direction. My y min is my amplitude, negative 3 and positive 3. We can leave that scale as 1. So if I graph it, I get a good look at what it actually should look like. And I've got one period going to the right and one period going to the left. If you have your mode in degree, this is what it would look like. Just a straight line, which is wrong. So make sure you've got your mode in radian. Okay. Let's talk a little bit about phase shifts. A phase shift moves the graph from left and right. So if you add or subtract a number from the x, it moves the graph left or right. So we're going to flip the sign and divide by x's coefficient to get how far it moves. So here's an example. Here's my number that I'm subtracting from the x. It's inside the parentheses. So I take that number and I divide by the number in front of the x, which is a 1. So my graph is going to shift from its normal position for cosine. It's going to shift right because this is a minus. That tells me to go right. Positive tells me to go left. Okay. So this moves cosine to the right by half pi. So let's graph cosine. I'm going to graph the parent function. Cosine looks like this. And then I'm going to take every one of those points and I'm going to move it to the right a half pi. So this one moves to here. This one's going to move there. This one's going to move a half this way. This one's going to move a half this way, and so on down the line. So when I've done that, the red line is y equals cosine of x minus pi over 2. What does the red look like as far as another function? It looks exactly like y equals sine of x. That's what happens when you subtract pi over 2 from the x in cosine. You get sine of x. And likewise, if you had sine of x minus pi over 2 and you graphed it, it would look like cosine. Okay, so let's try this. Let's graph sine of x. Sine of x goes through 0, 0. There's sine of x. I'm going to take every point. I'll take my pi over 2. I'm going to divide it by the number in front of the x, which is 1. So I get a phase shift of pi over 2, but they're going to move left pi over 2. So I'm going to take every point and move it left pi over 2. And I'm going to connect those points. And there's my graph of y equals sine of x plus pi over 2. And it looks just like cosine. Okay? I always want to do the phase shift first, then the period, and then the amplitude. So let's look at a graph that encompasses all three. Phase shift first, then period, then amplitude. My phase shift, my amplitude is 1. My period is going to be the 2 pi divided by the number in front of x, which is 2. I get pi. My phase shift is going to be the number added or subtracted to the x, pi, divided by the number in front of the x, pi over 2. Negative means it goes right. So I'm going to draw the graph of cosine as a dashed line. I'm going to move every point to the right pi over 2. I need points every 1/4 pi. So at pi over 4, pi over 2, 3 pi over 4, and pi in both negative and positive directions. And my amplitude is going to be 1. Okay? So here's my graph of cosine. I've already got the points I need. We're going to move it right pi over 2. The period is pi. So I need points here. I need a point here, and I need a point here. Every 4th pi. Amplitude is still 1. I'm going to shift all those points to the right, pi over 2. Okay. I want you guys to graph that in your calculator and give me a final graph on that. And the last thing we're going to talk about is what do numbers do on the far right of the equation that are not inside the parentheses with the x? Well, it moves it up or down. Plus will move the whole graph up. Minus will move the whole graph down by whatever number is there. So if I wanted to graph y equals sine of x plus 1, I would graph sine of x, move every point up 1. So here's sine of x. And I'm going to take every point and move it up 1. And that is the graph of y equals sine x plus 1. So we've been through everything about graphing a trig function. Remember, it's always easiest to graph the parent function, which would be sine of x, cosine of x, or tangent of x. Graph that as a dashed line first to help you get the other transformations to plot. Please stay on the Zoom if you have questions, and have a good day.